Bismillah ar-Rahman ar-Rahim. We have here 2D force system resultant, and these laws we already take it like we see here, law of sines, law of cosines, and here Pythagoras law, and we see here the resultant equal sigma f and equal the square root of rx square plus ry square, and here we see the theta x equal tan inverse ry divided by rx. Here we have two forces, F1 and F2. F1 equal 30 Newton and F2 equal 10 Newton. The question is determine R and theta of x. First we write the sigma of fx equal 30 multiplied by the angle cosine 45 plus 10 multiplied by cosine 30. This will be equal 29.9 Newton, and sigma fy equal 30 sine 45 minus, like we see here, 10 sine 30. This will be equal 16.2 Newton. Now we have sigma fx and sigma fy. We can calculate the r equal the square root of rx square plus ry square. As we know, rx equal sigma of x and ry equal sigma of y. This will be equal 34 Newton, and the angle of x equal tan inverse ry divided by rx. This will be equal 28.4, and we have here the resultant and the angle. Thank you for listening.
Second example. Replace the force system acting on the post by a resultant force and a couple moment at point O. Basically the same procedure. I need to apply these equations. First two equations says that all the forces has to be resolved into x and y components, otherwise I cannot add them up in the x direction or in the y direction. So I resolve the forces as shown. If I apply them, I will have 300 cosine 30 minus 150 5 over 4 plus 200. That will give me 339.81 pounds. Now if I apply the summation of the forces in the y direction, I will have 300 sine 30 plus 150 3 over 5, and that will give me 240. Now I get the resultant force by taking the square root of the sum of the squares, and I will have 416.02 pounds, which is approximately 416 pounds. And then for the angle, I'll take the inverse of the tangent, which is 240 over 339.81. Take tan inverse, and I will have 35.23. That should give me 35.2 to make it simpler. Now if I take the summation of the moments, I can see that I don't have any concentrated moments about or in the system in general. Again, assuming that the counterclockwise is positive, I will only have the moments produced by the components. About point O, you will realize that two of the components, as shown in the figure, will pass through the point of interest, so they will not produce any moments. In this case, I will have the following: 150 4/5 times 4 minus 200 times 2 minus 300 cosine 30 times 6. The 4, the 2, and the 6 are the distances, and the 150 4/5, the 200, the 300 are the forces. And if I sum them up, I will have negative 1,478.85 pound-feet or pound-foot. So what I did is I transferred this system with all its forces into this system with a single force and a single concentrated moment at the point that I specified in the first or in the beginning of the questions.